Hello, Algebra 2 students. Today we are going to start Chapter 2. We are going to do 2.1 and 2.2 notes. 2.1 is called Represent Relations and Functions. A relation is a mapping or pairing of input values to output values. Our first example, write the relation represented below using each method. There are 4 methods here. The first one is ordered pairs. If you notice, the first number in the ordered pair, -2, is the input and the output is +2. That's the same for the remaining points. For the first one, the mapping diagram, you would put the input in one box, so -2, and you would put its output in the other one, and you draw an arrow from the input to the output. For the second ordered pair, you would put 0 and then 1. For the third order pair, you would not put -2 because you already listed it on the very top. But you do put the output. I did forget to draw an arrow from 0 to 1. But this -2 also has the output. This input -2 also has an output of -2. And then finally, 3, its output is 1. And that is a mapping diagram. The third method is a table, which a lot of you are familiar with when you learned it in Algebra 1. So for the x values, you put the x coordinate of your point. So you put -2, 0. You could put -2 again because each value does go in the table, and then 3. For your y values, -2's y value was +2, 0, x value was 1, -2, and 1. And then lastly, you graph the ordered pairs. So this first one, -2, 2, would be left 2, up 2. Starting at 0, remember, you crawl before you walk. So you go right and left first, and then up and down. So 0, 1, then left 2, down 2, and finally right 3, up 1. And you don't need to connect the dots because it is not an equation of any sort. The domain of a relation is the set of input values. The range of a relation is the set of output values. So more vocabulary. So basically what it's saying is a fancier word for input is domain, and a fancier word for output is the range. And if you notice, this is all alphabetical order. X comes before Y in the alphabet. D comes before I in the alphabet, and then R comes before O. Actually, I said that backwards. So O comes before R, but they go together. Okay, so for the relation above, the domain would be these numbers, -2, 0, and 3. I didn't list this one twice because I listed already once there. The range would be the second numbers. So 2, 1, -2, and again, I'm not going to write 1 again twice. So there's some basic vocabulary. Okay, now we're going to go to describing a function. A function is a special type of relation that we just mentioned up above, for which each input has exactly one output. And if you have a highlighter, either highlight it or underline this. Each input gives you exactly one output, not more than one, or just one, not more than one. So tell whether each relation is a function. Explain how you would know. So if you look at the input -2, it maps with just a -1. So that input has one output. Let's look at the bottom here. 6, its output is 4. So that satisfied one input has one output. 3 also has only one output and it's 0. And -1 also has only one output. It happens to be the same number, but that's okay. There's only one arrow leaving each of the numbers on the left side. So this is yes. Each input has exactly one output. Okay, looking at problem B. So -2 has only one arrow leaving from it. 1 has only one arrow leaving from it. But here's the problem. The number 2 has 2 arrows leaving from it. So this is not a function. So no. The input 2 has more than one output. It all goes back to drawing this, and drawing it really makes sense. So if the 2 arrows are leaving from the same number, then it's not a function. But if only one arrow leaves from x to y, then it is a function. So basically, x values cannot repeat. Okay, there's another way to test to see if a relation is a function, and that is known as the vertical line test. A relation is a function if and only if no vertical line, and vertical line, remember, is up and down, intersects the graph of the relation at more than one point. So what does that mean? So in each of these examples, we're going to tell whether or not that relation is a function. So the question is it a function? So what you do is you draw a vertical line anywhere on the graph. Oops. And I just drew it right there, but you could have drawn it right here. And you have to figure out how many times it touches that graph. Here it only touches once, there it only touches once, and so on. So if it only touches the graph in one spot, it is a function. Okay, so let's look at example 2, or example B, sorry. If you draw a line right here, notice it touches the graph in 2 spots, right there and right there. So this is not a function. Next one, I can draw a vertical line. For these solo points, you want to draw a vertical line through every point. And notice it only crosses the point once. So yes, it is a function. The next one, here it's okay, because it only touches once. Here it's okay. There it's okay. Look, here it's not okay, because it touches twice. Same with here. So this is no. Okay, for E, a circle would definitely not be a function because anywhere you draw a vertical line, it's going to touch the circle in 2 spots. So that is no. F, so you can draw several lines here, there. It's always going to be only one spot that it touches the graph. And then lastly, G. Again, draw as many lines as you want to convince yourself. But notice everywhere it only touches the graph at one spot. So yes. And that is the first page of our notes. So the second page of our notes is graphing equations with 2 variables. So we already talked about y equals mx plus b, where your variables were x and y, and you've seen it already. So examples of a linear equation with 2 variables could be something like this, just as I mentioned, in y equals mx plus b. Or it could even look like this. As long as it has x and y, or either one, it is a linear equation, but when it has 2 variables, you would see x and y, or a and b, or and so on. The input variable is the independent variable, and it's x. The output variable is the dependent variable, and it's y. And think of it this way. Y is dependent upon what dependent upon x. So x can take on different numbers. X can be 1 here, it can be 2, and then you would multiply by 4, add 2, and that'll give you the output y. So x changes, and because x changes, y will be dependent upon it, and it will change as well. An ordered pair, xy, is a solution. We've already talked about solutions. It makes an equation true of an equation in two variables if it satisfies the equation or it makes it true. And lastly, the graph of the equation in two variables is a set of all points x comma y that are solutions. So what are the steps in graphing an equation in two variables? I've laid it out here for you pretty simply. First of all, you would make a table. Next, you would plot the points. Third thing you would do is connect the points to form a line or a smooth curve. It depends. In this chapter, we are going to talk about lines for the most part until we get to the end of the chapter. So let's do our example. We're going to graph the equation y equals negative 2x plus 1. So the first thing we want to do is make a table. You can make a horizontal table or a vertical table. I recommend making a vertical table because you have more room to work. Label it xy. And always make my y a little longer because that's where you need to show your work if you can't do some of the stuff in your head. We want to do at least 3 points here. It takes 2 points to make a line, but if you make a mistake, you want to be dependent on the third one. You want to try and pick positive and negative numbers. Pick the smallest ones you possibly can, and only do fraction values if you need to. So I picked the basic easy numbers, -1, 0, and 1. And what I'm going to do is I'm going to take each of these numbers, the -1, and I'm going to replace it right there, multiply by -2, and then add 1. And I'll show my work in here. So I'm going to take the -2, that's part of my equation. I'm going to times it by the x value, which I chose, which is -1, and then I'm going to add 1. So negative times a negative is a positive. That's 2 plus 1. It equals 3. Okay, for the next one, be -2 times 0, which is just 0, and 0 plus 1 is 1. And the last one, -2 times a positive 1 plus 1, that is -2 plus 1, which is -1. And so here are your ordered pairs. We have -1, comma 3, we have 0, comma 1, and we have 1, comma -1. And so we're going to plot those 3 points on our coordinate plane. So we go left 1, up 3, stay at 0, go up 1, go right 1, down 1, and notice three points are in a line. So we're going to connect it. We're not just going to connect those dots, we're going to connect past them so that we know and everyone else knows that the line will continue infinitely. So the domain, we could have picked any numbers for x, but we decided to choose these small numbers. But I could have picked -100. When you can pick any number you want, that's called all real numbers for x. And there's an easier way to write this. Instead of writing all real numbers for x, you would just you would make an R like this, and that means all real numbers. So there we go. So you know where you get the R from real numbers. The range, if x is going to be all real numbers and there's no fraction involved, the range is going to be all real numbers as well. So all real numbers. But for y, because remember what we said, domain means x for input, range means y for output. And then lastly, if we were to draw a vertical line, which I'm not going to do to this graph, it's so pretty, but if I were to draw a vertical line anywhere on that graph, it will only touch the graph at one spot. So yes, it is a function. And you can say what reason it passes the vertical line test. Only use the vertical line test as a reason if you have a graph. If you don't use that as a reason. You would want to use each input has exactly one output. And if you look here, -1 only has one output, it's 3. 0 only has one output, and 1 has only one output. All right, we are almost done with our notes for 2.1. A linear function can be written in the form y equals mx plus b, where m and b are constants. The graph will be a line. We're going to write the equation in function notation. And when we use function notation, your ordered pairs, instead of writing x comma y, we would write x comma. And another fancy way of saying the letter y, and you'll learn this in later chapters also, is f of x. Just a fancy way of saying y. That is what function notation is. But you need to know both of those, especially in later math that you'll take and pre-calc, later on in Algebra 2. X and Y is for basic when you learned Algebra 1. And then we talk about X and f of x, that's just function notation. Okay, so for these examples, you're asked, is the function linear? Well, if it's in the form y equals mx plus b, it will be linear. If it is linear, we're going to evaluate x equals -4. Actually, we're going to evaluate it anyway. So let's look at example A. Example A would not be linear because there's a 3 here. So not linear. It can only be x to the power of 1. This part's fine and this part's fine. Had this not been there, this would have been linear. And now let's find f of -4. So if you go back up here, notice x, this is not f times x, it's f of x. So this x is your input number. And so what if this x is -4, we write it like this. What is the function when x, what is the function's value when x is -4? That's how you read that. So what we're going to do is we are going to replace in this equation, wherever you see an x, we're going to replace it with -4. We always replace using parentheses or you lose a sign. Now notice I have to take this minus sign right here. Oops. And I have to put it right there. And now I'm going to replace the x, and x is -4. And then I'm going to do my math. So this is -4 times -4 times -4, an odd number, and this is negative, so it'll be -64. Plus 6, and here a negative times a negative is a positive. So 2 times -64 is -128, plus 6, plus 4. Left to right, do those two first. And then add 4. That would be -118. Okay, let's do the second one. The second one is definitely a y equals mx plus b. Remember, this is a fancy way of saying y. So y equals 4x plus 9. So yes, linear. And then let's find what y equals when x is a -4. That's going back here. So we would multiply, you would replace this x on top in the equation with -4, multiply by 4, and then add 9. It's -16 plus 9, that would be -7. And those are your notes for 2.1. Now we're going to move to 2.2. 2.2 is finding slope and rates of change. Slope is the ratio of the vertical change to horizontal change. Or, in simple terms, rise over run. for any non-vertical line. There's a formula instead of using rise over run, so slope is denoted by the variable m, and its equation or its formula is y sub 2 minus y sub 1. I say sub because sub means subscript. I'm too lazy to say y subscript 2, and I know you would get lazy too if you had to say it over and over and over again. Bottom would be x sub 2 minus x sub 1. Some people just say y2 minus y1 over x2 minus x1, and that's totally fine. Where can you run into problems? If you put x on top. And just think, rise means up and down. So rise means up and down. Run means right or left. And that's how you know rise refers to y, because y-axis is up and down, and run is your x-axis. This is known as the slope formula. Okay, there are, and I think you've seen it before, but we're going to draw Mr. Slope Man here. Draw a round circle. I'll do the best I can with what I have. And then you're going to draw eyes that look like that. Hopefully not crooked. Vertical. Mr. Slope Man looks sad, which, hey, let's put arrows at the end of these two lines. We could for all of them. Okay, so what does that mean? What does his face represent? So each of those four pictures represents positive, negative, zero slope, or undefined slope. So this particular one is positive when the line goes up from left to right. So left to right. I'm not going to write in here but you're always looking left to right. When it goes down from left to right, it's a negative slope. This right here is a U for undefined. And these zeros right here, or circles, represent 0 for zero slope. So now that we know what Mr. Slope Man's face looks like, we can go ahead and classify the lines by slope. So a positive slope, the line rises from left to right. And I showed you that so left to right, it goes up, the line rises. A line falls from left to right would be a negative slope. So here's the left side, right side. And then a zero slope, the line is horizontal. So think of the horizon. And if you go back to basic fraction skills, if you have 0 in the numerator and you're dividing by whatever number is in the denominator, it's okay to do. Okay. It's not okay if 0's in the denominator. It's bad. So lastly, the line is vertical. Or if a line is vertical, it has an undefined slope. So draw a vertical line. You have a number in the numerator and you'll always have 0 in the denominator for something to be undefined. You can never divide a number by 0. It is not allowed. So no. So a number in the top is okay. A number in the bottom, or 0 on the bottom, is not okay. 0 is only okay on the top. All right. Examples of slope. Draw a graph of the line. Find the slope of the line using 2 points. Classify the line as rising, falling, horizontal, or vertical. So we have 1, 2. So right 1 up 2, and then right 2 up 5. And the easy way to do this particular problem is we're just going to do rise over run. So let's go ahead and connect it. Okay, and we're going to draw a triangle from the bottom point to the top or vice versa. Doesn't matter. But you always, wherever you start, if you're going up, you're rising. So you're rising 3 squares. So that's a plus 3. And then you're running right 1. So that's plus 1. So our slope is rise over run, which is 3 over 1. And don't leave it like that. Make sure you divide completely. It's just 3. And so the slope is 3. And then since it's positive, um, the line rises because the slope is a positive number. All right, let's do the next one. Go right 3, up 1. Go right 1, up 4. Connect the points. Oops. Maybe not do such a bad job like I did, but that's okay. This time I'm going to start here and make up my triangle that way. But like I said, it doesn't matter. You just have to be. So from here going downwards, we fell 3 units because we went down. And then we went right 1, 2 units. So your slope, rise over run, equals -3 divided by 2. And we don't write that as -1.5 or -1.5. We leave our slope as a fraction if it is a fraction in simplified form. And that slope is negative, therefore the line falls. Okay, next example. What is this doing? It's solidifying your graphing skills for one, and then you're remembering what slope is. So go right 2, down 1, right 2, up 2. Connect the dots. And then we are going to do rise over run. Notice here, you're not running at all because the line keeps going up and down. So your run is 0. Doesn't matter what your rise is, but from either point, if we went up this way, we're going up +3. If we go the other way, we're going up -3. It doesn't matter what number's here. If the number is 0 in the denominator, remember, that's not good. That's undefined. So it's an undefined slope. What do we call 3 divided by 0? Do we call it 3? No. Do we call it 0? No. We call it undefined. We don't leave it as 3 over 0 because that's not a true statement. And so if the slope is undefined, it's a vertical line. And then last but not least, 3, 1. So right 3, up 1, left 1, up 1. Connect the dots. Okay. Rise over run. This time you're not going up at all, up or down, but you're running 1, 2, 3, 4 squares. Never count from the dot. Count 1, 2, 3, 4, but count the last dot. So 0 divided by 4 is okay. So 0 divided by 4 is just 0. That is a slope. 0 slope does exist, and this would be a horizontal line. How would I know that's horizontal? Well, look at the number 0 and look at the letter Z. So there we go. And we are done with the front side of that page. Now we're going to use our slope formula to find the slope between 2 points. So not everybody likes to graph. I don't. We definitely need graph paper in here. So if you don't have any, you need to make sure you have some very soon. So as far as graphing goes, if you're asked to graph something, you do. But if you're not, you're just asked to use the formula, then just make sure you have the right formula. So that what we're going to do is if you need to look on the front side of your notes, you can. But remember, the slope m is equal to y2 minus y1 over x2 minus x1. And the order does matter. So the top cannot be y2 minus y1 and the bottom be x1 minus x2. These numbers right here must match, and those numbers must match. But you can switch the order around. You can say y1 minus y2 over x1 minus x2. Totally up to you. So let's label these coordinates. So this is my first point. So this is my first point, and this is my second point. So this is x1, y1 because it's my first point, and this is x2, y2. And remember, x always comes before y, so that's why I labeled it that way. Now that we've labeled it, we should have no problem putting the numbers in the right spot in our formula. So m equals, okay, y2 is -8. Before we even do this any further, I would recommend putting the minus sign in top and bottom because it's part of your formula here and there. So always put that in your formula so you know that you have a minus sign already. So y2 minus y1, and y1 is positive 6 over x2. X2 is -2, and x1 is -4. So you could do it like that, or you could put this in parentheses. I sometimes just don't because then I know negative times a negative is a positive. So let's do this. So that's -8 plus a -6, which is -14. Whenever you have a minus right there, you can always put in a plus here to help you. So -2 plus 4. So that's -14 divided by 2, which is -7. And remember, since the slope is negative, this line falls. Not that it's asking us, but it's good to know. Okay, our next topic that goes along with slope is parallel and perpendicular lines. Two lines are parallel, and if you see the picture on the right, those lines are not crossing each other. If and only if they have the same slope. That's because they have the same slope. If they had different slopes, they would cross each other, but they have the exact same slopes. Two lines are perpendicular. This is a word from geometry. If and only if their slopes are opposite. I'm going to all caps this. Reciprocals. I don't know if I can fit it in here, but I'm going to try. RECIPROCALS. Reciprocals of each other. And remember, reciprocal is flipping the fraction. So the numerator would then become the denominator, and the denominator would become the numerator. So let's see, by using the slope formula, if two lines are parallel, perpendicular, or neither. So the first thing you want to do is label each point. So for line 1, this would be x1, y1. This would be x2, y2. For line 2, this would be x1, y1, x2, y2. Okay, let's do slope of line 1. And because my formula is right here, I'm not going to rewrite the formula. I'm just going to look above as I need it. So m is our slope. Remember what I said, put the minus sign top and bottom, and then your chances of making a mistake have been reduced greatly. So y2, and if you don't label it, you might put the number in the wrong spot, like you might put 3 here. So it really is important that you label. Y2 and y1 goes here, x2 and x1 goes there. So that is easy math. 4 divided by 2, which is 2. Now let's do line 2. I like the habit that we do in math, and it's just habit, habit, habit. So putting the minus sign, looking at line 2 numbers, 5 and 6, 22 and 24. 5 minus 6 is -1. 22 minus 24 is -2. Okay, now let's go back up here and write 2 just for this problem as 2 over 1 because it's the same thing. Now let's look at the slopes. One of them is 2 over 1. The other one is, I didn't finish this one. Negative divided by negative is a positive. Yes, they are. These two are reciprocals because the numerator and denominator here switch, but they're not in opposite signs. They're both still positive. So this would be neither because even though they're reciprocals, they're not opposite reciprocals. Okay, let's do 2b, x1, y1, x2, y2, x1, y1, x2, y2. Okay, line 1. So 5 goes here, and negative 1 goes here. Don't forget that negative. And then the bottom, we have 1 goes there, and oops, my bad, I did that wrong. 2 goes, hold on. I'm looking at line 2's values, so sorry. So 2 goes here, and a negative 3 goes there. So we have 5 plus 1 over 2 plus 3. That's 6 over 5. Okay, now let's do line B, or line 2. Okay, y2 for line 2 is 1. y1 is negative 4. x2 is negative 3. x1 is 3. Negative 3 minus 3 is not 0, guys, which a lot of you think it is. You have two negative numbers, so you're adding and you're keeping the sign. And that's 1 plus 4. So we have 5 over 6. Let's compare 6 fifths and 5 sixths. Oops. It's actually 5 over negative 6. I just saw that. So notice this number here on top has become bottom here, and bottom there has become top there. And they're opposite in sign. This one's positive, this one's negative. So these are perpendicular because they are opposite reciprocals. Right. Last problem, a word problem. In 1983, 87.5% of the land in New Hampshire was forest land. By 2001, 81.1% of the land in New Hampshire was forest land. What is the slope of change in the forest land? So that's what we mean by rate of change. So let's write down the years as our x value. So 1983, and we had 87.5%, so as a decimal, that's just 87.5. And our second ordered pair is 2001. In 2001, 81.1% of the land was forest land. And now we're just going to find the slope of change. So let's label our points x1, y1, x2, y2. M equals, again, going back to our favorite slope formula, y2 in the first slot, and then y1 in the second slot, x2 in the first slot, x1 in the second slot. From 2001 to 1983 is a total of 18 years. If you subtract that, I just used a calculator, you get negative 6.4. And when I divided that with my calculator, I got about negative 0.35, in which the 5 was repeating. And so that would be, and then remember, we moved the decimal point over 2 places to the right. I'm just going to go ahead and put another 5 there. So that would be 35.5%. That's the change in forest land per year. Slope is per unit of time. In this case, it's per year because we're measuring time in years. And that's it for today. Have a great day, Algebra 2 students.